Hello, this is CIT 371, Linux System Administration. In this lecture, I'm going to provide some additional scripting help. Now, this lecture is meant to supplement the previous one I did for providing the fundamentals, or talking about the fundamentals of bash scripting. This lecture is to show you how to apply these fundamentals when approaching scripting problems in this class, and in the future in general. Now, it can be tempting to just jump in and start scripting when you're presented with a prompt in a lab or so forth. And if you're skilled enough at scripting, or if the problem's simple enough, this can work fine. But if you're faced with a more complex situation, or if you aren't familiar with bash scripting, typically more effective to start by taking a step back to analyze the problem before you. Doing this can result in improved script design, less frustration, and more efficient script writing. I'm going to provide the following steps here to help you improve your scripting experience. I'm going to cover understanding when to use certain forms of programming logic, how to use pseudocode and flowcharts, how to select the best programming language for your problem, which in this class is Bash. No one have much of a choice in that regard. And then how to consider dividing your script into functions for organization and clarity. Programming logic. So most scripts are simply a list of commands or tasks that are automatically run upon execution. Programming logic, however, is often needed to determine which tasks to perform based on certain conditions, also to prevent code from being run until a certain condition is met, and finally, to repeat tasks for different variables. I talked about if statements, for loops, and while loops in the previous lecture. I'm going to show you some examples of when to use these. Here's some information on when to use these. So, if statements are best used to perform input validation. You can also allow a script to continue when it has received valid data, and then terminate if invalid data is given. So if statements are good for input validation, making sure users provide the right input. For loops are great when you need to repeat certain tasks for multiple variables or values. Like for example, if you have a list of users and you need to add them all to a group, you can make a list of the users and then like for user and users, and then use a command to add these users to a group instead of running a single command over and over and over again manually. So while loops are good to repeat code until a certain condition is met. So I'm going to provide a little example here. So say you receive a problem that asks you to allow a user to enter multiple usernames, which will then be moved to the student's group. Script should check each username to ensure it is valid, prompting the user to enter one if it is invalid. So we're going to use the while loop to allow the script to repeatedly prompt the user for a valid username until all usernames pass the test. While all underscore users underscore valid equals false, do this. So if you receive an invalid username, you ask the user to keep repeating one. So for example, let's say we had under this while loop code that determines that a user exists in the system. If a user gives out a username that doesn't exist, the script is going to prompt the user to try again. Then we have a for loop to allow the same validation check to be ran on the usernames individually. So for example, say the user provided a text file full of users, and each one is checked. So this variable would store all the users in the file, and then this while loop would ask the user to a while loop could be used to ask the user to clarify a username, to give an accurate one. Finally, an if statement can be used to validate each username. So if fake underscore user underscore test equals 1, then that could be the if statement can be used to validate the username. The while loop can be used to ask the user to give another one, and then the for loop can allow this validation check to be ran over and over and over again. So that's how these three constructs are used in a programming or a script. Okay, pseudocode. So pseudocode basically allows you to write in real words, non-programmatic words and sentences, to represent the task and logic of a program. This helps you better consider these things before scripting. Pseudocode makes designing your script significantly easier than having to work with specific commands or syntax. Now you can live write your script while thinking about the syntax you need and stuff, and the logic, but pseudocode can make this a little easier. So after you prepare the foundation of your script with pseudocode, you replace the sentences and phrases with your commands and syntax. So basically, you're building the skeleton of your script with pseudocode and then filling it in with the actual code. So let's say we have a problem where we need to write a script that accepts an IP address and performs NSLOOKUP on it. We have to validate these IP addresses, and if an invalid one is received, we have to use the user to try again until a valid address is given. So let's say we set up a variable to false, valid IP to false, for our while loop. So request the user input IP address. We store it as a variable. Now, while this is false, we check if the IP address is valid. If the IP address is valid, then we perform NSLOOKUP and then set this valid IP to be true to break the loop. So basically, sending a while loop, while equals false. If the IP address is false through an if statement, then we repeatedly ask the user to give a proper IP. If it is invalid, then we prompt the user with this else statement, and then we store the IP as a variable, and the while loop repeats. We check if the IP is valid. If it's invalid again, we repeat. We check it, and then if it is valid, we run the NSLOOKUP command on it, and then we break out of the loop with changing this variable to true. A flowchart. So similar concept to pseudocode, where we're basically just mapping out our script. But flowcharts use symbols and lines. So here's some common shapes. An oval represents the start and end of your script. Arrow basically connects the shapes to show relationships. So basically, it just flows from one, shows you the order in which the shapes are connected. Parallelogram is input or output. Rectangle is a task or process, and the diamond is a decision. So here's the flowchart. I'm going to explain this one. So the oval, you start with an oval, which means start. This is where the script starts. We have a process here where we're setting a valid IP to false and setting that variable to equal false. So we have user input, receive an IP address. We have a diamond here to represent a decision. Parallelogram is the input. Diamond is the decision. We're checking if the IP address is valid. If it's not, we have a directory where we go back to ask the user for an IP again. If it's valid, we continue on to set the valid IP to true to break the loop. We run NSLOOKUP with the IP address, and then we end the script. Functions. I don't require functions for this class. I do recommend them, though, because they allow your programs to be easy to read and understand. They also save you time by having to keep you from having to write code over and over again, or repetitive code over and over again. The functions, like I said in the last lecture, are blocks of code that are used when they're called. They can be recalled and therefore reused repeatedly. Functions are best used in longer scripts or ones that contain repetitive lines of code. So that's basically it for this lecture. Again, the supplemental resources in that specific page for this module are going to be a lot of help in applying what you've learned. But I hope that this lecture gives you an idea of how to apply programming concepts. So again, if you need my help, I am more than welcome to help. I'm more than happy to help you. Thank you for your time and have a wonderful day.